Hello, in this second set of videos we're going to be looking at the use of variables, how we can change variables using operators, how we can generate random numbers for variables, and the basics of declaring variables, making sure we use our header correctly. So down here we have our classes. If you do a quick search for BP_generator, I'm going to drag that into the level, and this is what we're hoping to end up with at the end of these tutorials. So I've started the level, and you can see it's randomly generated a series of rocks and bushes over the landscape. Now, just hit escape there and stop. I'm going to delete that from the world outliner, so I'm going to remove that from the level. And I'm going to look for my other blueprints that I've made, and I'd like to bring in scenery generator. And let's start this. Now, all that we've created here is, or at least appears to be, a single rock. There is actually also a tree, a bush hidden under there that you can't see at the moment. Now that's done deliberately. We want to have a look at changing the variables to change the location of those objects. So scenery generator is what we're dealing with. So quick search for scenery. We're looking under C++ classes now. And if I load that up, Visual Studio should automatically start, and in a few seconds we'll be able to see all of the code. So here we have Visual Studio. You can see our scenery generator.cpp and the scenery generator header file, the .h file here. In the header file, one of the first things I've done is to include the scenery class. This is another class that I've got set up. It's the class that actually contains those rocks and bushes that you've seen before. So you'll remember from our first lesson, if we're going to reference any other classes, those must be included in the header. And very importantly, they should not be the last thing included in the header. The scenery generator.h, the header file itself, is listed here. Now, the other variables that I've declared, don't worry about these first three. They're a bit more complicated. We're going to look at those in a later session. I'd like to focus on these. We've got scenery x and scenery y. These variables are going to control the x and y coordinates of all of our objects, the trees and the rocks that we're going to be generating. And the object count is going to control how many of those we are generating each time. Now for object count, we can generate one object, we can generate 50 objects, we can generate 50,000 objects if we so choose. What we can't generate is 1.5 trees, or 3.9 trees, or minus 0.8 trees. It's always going to be a whole number of objects, so that's why that's declared as an integer. Now the x and y locations are given in pixels. So I can either move by 1, 5, 50,000 pixels. You can't actually move by 0.8 pixels, or that wouldn't be visible on the screen. So why have those as a float, as a decimal number? Well, we may want to make objects move over time. For example, I may wish it to move by a single pixel over 10 ticks. An easy way to achieve this is to have a tick event that will change that variable by 0.1 every tick. So every 10 ticks, that would add up to 1 pixel. So just in case you are going to be doing anything that's moving these over time, you want to have those set as a float. Let's have a look at our CPP file, where all the action is happening. To start off with, I'm going to set my scenery X and my scenery Y here, both to 100. So that is 100 up and 100 across from the starting point. And the object count, we're just going to have 1 at the moment. So we generate 1 of each. So what actually happens when the game started? Well, we have a loop here, which is something that we're going to have a look at in our next session. But the important thing is that this is going to happen a number of times equal to the object count. So our object count is currently 1. So this is going to happen 1 time. And we're going to define our x and y locations and spawn a tree. Then we're going to redefine our x and y locations and we're going to spawn a rock. And at the moment you'll see that both of these are set to the exact same values, which is why when I come back to the Unreal Editor, put in scenery, scenery generator, and run it. There we go, we have a single rock, and where's the bush? Well, you can't see the bush because it's smaller than the rock and it's at the exact same location. So that's something we're going to want to change. So back into Visual Studio, we're going to use our first operator. An operator, we're usually talking here about arithmetical operators, which are plus, equals, minus, divide, multiply. Before we spawn the rock down here, I'm going to change the X location. Instead of just setting it to scenery X, let's set it to scenery X plus 100. And that's to change the X coordinate by 100 pixels. Now, if we want to see this, don't forget we need to compile before it will run. I'm just going to pause the recording there whilst this happens. And our compile is complete here. So if we now play, there's the rock, and we can just see the bush has changed its location slightly. So, back into the code. We want to separate those a bit more. So, let's change its X by 500, and we're also going to add 500 to the Y location. So, compile again. Bear with me whilst I pause. So that's compiled again. Let's play our level. And great, you can now see that the rock and the bush are definitely generating at different locations. This is something you should have a play around with at this point, as well as adding to the location. We could instead change the X location by minus 500. We can use multiply, divide as well in here. Usually when we're dealing with locations, plus and minus is all that we need. I'm going to compile that once more. And let's have a look at the new location. Okay, so the bush and the rock, again at different locations because I have changed those variables. So I'm going to show you a couple of other ways that we can set the variables here. Let me undo those changes. So that was directly setting scenery location.x and scenery location.y. Let's change our initial variables instead. So here we're going to set scenery x. I'm going to say plus equals 50. That is the same as, I'll add this in the comment, if I said scenery x equals scenery x plus 50. So I've added that in the comment so it won't change. But plus equals 50 is a shorthand version of writing it out like this. So if I wanted to change scenery y, make sure that's capitalized, plus equals 50, and I'm sure it should be obvious now that that is a shorthand version of writing scenery y equals scenery y plus 50. And there's an even shorter version if we just want to increment by 1, where we can type in the name of the variable, scenery y, and just plus plus. Or if we wanted to subtract from that, we'd say minus minus. And that will change it simply by plus 1 or by minus 1. But we're changing by a bit more than that. And we're going to do the same before we generate the rock. So I'm just going to copy and paste this. And we'd like to move it by a bit more than 50, so we're going to change it here by 200 and here by 200. Let's get back into our world, compile it once more, and have a look what happens. Okay, so we've got our rock and our tree here. Now, the advantage of doing it this way, putting this within a loop, is if I go back to the code here, the object count. That's currently set to 1, so it will generate 1 of each. Let's set that to 5, so we're going to get 5 of each object. That's going to give us 10 in total. Back into Unreal. Always remembering to compile. And after successfully compiling, we'll play one more time. And we should find now that we've actually got a range of rocks and bushes here. Now, they're all appearing in a straight line, which looks kind of odd. It doesn't look very natural, but we are getting multiples of them to generate just from that one small section of code. So in the next video, we're going to have a look at how we randomize these. We're going to generate random numbers in order to create a more realistic and natural looking distribution of objects.